Okay, so we are starting with the electric field due to ring, and remember that this electric field, we already talked about that xy components go away, and this was the z component already, so we are already having that. We don't need to take it like cosine theta or whatever the angle is, we find. We've already done that, okay? So simply using this dE, as you can see it on this right side, and integrating it, and on the right side it is with respect to dr, because we are going to change that dq. So using that, let me show that here. So we are, what I'm saying is this is dq. Let's plug this for dq here, and then integrate for over dr. Okay, so from here to there, that's what we did. So we did replace dq with sigma 2 pi r dr. And when you put the sigma, it multiplies with z at the top. It comes out, they're both constants. So you're putting all the constants out of the integral. And what else we have? We have 4 epsilon naught. What happened to pi? When you put that dq, there is pi here and this pi there. They will cancel out. That's why it disappeared here. And what is left will stay in the integral because they have an r dependence. Okay, the functions have r dependence. So we have that 2 pi r became 2r, so it's here. And this z squared plus r squared to the 3 hells, it's here, it's at the top, so you have to make the power negative because you're flipping it. And now, looking at the functions, you cannot take z squared plus r squared to the negative 3 halves out of the integral because there is r in it and you're integrating over r. So please keep paying attention on what you are integrating over. Okay, in this case, we are integrating over r. Remember that the ring, it was integrated over s, the arc length. Now we are doing it like over r, so we're integrating through the radial distance. Okay, so that hopefully that part is clear. Clean up a little here. So we have to solve this integral, and let's see. This again, this is the constant, so this part is what we need to solve. You might be able to look for some like integrals from a book or something, but what we are going to really use is going to be that. But before doing that, we need to think about u substitution. So I will show that. And here. So this is what we have as our integral. And I'll show you how we're going to do this u substitution as you learn in calc, right? And again, if this is your first time, and it's really not your first time because you've done this in calculus, but I know you probably didn't apply it to any other classes much yet. So it may not be straightforward, but once you do a couple u substitutions, you really know what you're looking for. And I have a typo here. This is not u yet. This is r still. So we have r term in the first term and then another r term in the second term. And what we're going to say that is that this term, we're going to say this is, let this be u squared. So z squared plus r squared is u squared. And if you take the derivative of both sides, you would get 2r dr equals to 2u du.